This is an example of using array fill method, which allows you to essentially assign certain values to the entire set of elements inside of your array. So if you want all elements to be set to a specific value, you can just say fill. You can also specify ranges of elements inside the array and limit it to a specific range. So in this example right here, what we have is we have an array of 5 integers, right? So there's like 1, 2, 3, 4, and 5 integers, and we have an array of them, right? So they reside physically inside this array object named quantities. So quantities, of course, is pointing to this array. This is our array reference. Now we say that let's fill quantities with specific value. And the range we specify here is 1. Of course, this is 0, this is 1. So we say that 1 is right here, right? So we specify from here to number 4. So 0, 1, 2, 3, 4. Okay, and number 4 specifies this location inside the array. And we say that let's fill. However, this range is called half open range. It means that the first element is included. The second element or whatever element before the last element are also included. All of these elements are included in the update of this fill. However, the last element is like a stop sign. Basically, this value says, and now stop, don't update this one. So this is basically how this range of fill parameters works. It's half open range. We say that this one is included and this one is excluded. That's why we say half open. Okay, so here we have the closed range and here we have open range. Basically, this one is not included. In math, usually you use like parentheses with this and square bracket with this. So this is the way the fill range version of fill method inside arrays works. Just remember about this half open range. Relational operators like equals, not equals, when you use double equal sign, for example, between the two arrays, what needs to happen is that it will simply determine, okay, it will simply determine whether one array object and the second array object, so if we have two objects that we're trying to compare, so this is array 1, for instance, and this is array 2 right here, it simply compares whether locations in memory of these two arrays are the same. Basically, if array 2 was pointing to the same array, then equal will return true. If not, if this is a different array, then of course it will return false. So double equal sign applied to array names works in cases if you want to compare memory, but most of the time you probably want to compare the content, the actual values like these strings or these values, whether two of your arrays contain the same values, right? So for that reason, there is an equals method inside arrays, and so equals method, basically this is an example of it. So we have some arrays of strings, and here it says equals, and in case if the content is exactly the same, it will print that arrays are the same, or basically it will return the true value. So of course you can use it with objects that allow comparisons, which will be discussed in the second part of our presentation about arrays in our next section. And sort we already used in our example, sorting strings, and here is some integer values that obviously appear to be unsorted, and it's very simple. You just if you apply sort to all of these, if we print them, you see how they become all arranged nicely in ascending order, and they're getting sorted. There is also binary search, which we will also discuss in the future in greater details in terms of its algorithm, but you can search for things inside your arrays by using binary search, but binary search requires that the array is sorted. So the idea of binary search in a very quick demonstration here. So let's say that we have an array of some elements, okay, and so these elements are all sorted. Okay, let's think about integers like 10, right, 20, 30, 40, 50, 60, and 70. Okay, so these are my array elements, and this array is already sorted. So then I would like to find out whether elements such as, for instance, 60 is present in this array. So the binary search, what it does, binary, it means like division by 2. So what binary search will do, it knows the length of an array, and it will find where approximately the middle is, right? And it'll say 60. If I'm searching for this value 60 right here, right? It'll say that the value 60 is greater than 40. So it will say there is no need to search here, because we already know that this value that we're looking for, 60, right? So the question mark is this value present in this array? So the lower portion of this array, after dividing it into 2 halves, it can be thrown away. We don't have to worry about it. Then with the remaining part, again, we divide it by 2. And we say, okay, so where is this element 60? Is it above in the upper half or in the lower half of this remaining part of our array? Of course, it's higher, so it's up here. And so it divides, and finally, of course, here it'll say, oh, here it is. We just found it, okay? Otherwise, it just keeps dividing and quickly dismissing large portions of an array by always dividing by half the remaining part of an array that it still needs to be searched. But the key part of it is that the precondition here is that the binary search has to be preceded by the sort. So if you have a really long array of elements, perhaps with like thousands of elements, thousands of values, and you know that it's not going to be modified frequently, but it's going to be searched frequently, then of course you probably want to keep it sorted, and then binary search will give you much quicker response time when you apply your binary search. And this is an example of search with an unsorted array. So what can you do with this unsorted array? You just sequentially start at the beginning, index is 0. As long as it's within the length of an array, you try to compare the elements. If you just found it, you just return the index and you say, okay, this specific index is the index of the searched item, right? So here we use sequential search method, which is static, which takes a reference to the array name list, and this is the item that we're trying to search for. Okay, so just another example of a possible implementation of searching sequentially through all array elements. So this is different compared to binary search. This is just any array can be searched like this. And the decision here is made that if we didn't find the item that we're looking for, we're returning -1, which we know is not a valid index.